Hey guys, hope you are having a fantastic day. We have so far been reviewing Unit 9. We started Unit 9, we came back from Christmas break, and we have gone over how to multiply exponents and how to divide exponents. Today we're going to learn what happens when you have a power to a power. So you have like an exponent to an exponent. And there's a rule for it, just like when we divided and multiplied. So first I just want to go over multiplying and dividing. So this first one, I'm multiplying, and remember the rule for multiplying. You're going to multiply numbers. So multiply those coefficients, multiply the numbers, and then you add exponents. That's the rule for that one, okay? So again, I'm going to take the 4 and the 3. We're going to multiply them, so I have 12. Then I move on to the exponents. So I've got x's first. So x is my base. Then I add the exponents, so 2 plus 5 is 7. Then I'm going to move on to the y. That's my base. And I'm going to add the exponents. 3 plus 4 is 7. So this would be my answer in simplest form. 12 times x to the power of 7 times y to the power of 7. Okay, these next two are dividing exponents. Okay, so in this case, we divide numbers, and this time we subtract exponents. Okay, so this one, I'm going to divide the two numbers, 12 and 4, and I'm left with 3. Then I move on to the x's. So in this case, the base is x. 5 minus 2, always take the top exponent first, is 3. Then I move on to y. So y is my base. 3 minus 7, it's going to be a negative 4. Now remember, if I have a negative, it's ugly and I can't keep it like that. I have to do the negative power rule, okay? And the negative power rule says to take this and put it on the bottom of a fraction to simplify it. So 3x to the third, that's all happy. Underneath it, though, I'm going to change this to a positive 4 to make him happy. Okay? And that's negative power rule. Again, that just says if I have a to the negative power of n, it's going to be 1 over a to the n. That was the rule. And I think that's the same terms they use here. Yeah, that's that rule right there. Okay, so far we've used product of powers. Again, product just means we're multiplying. We've used quotient, that just means dividing. And we have used the negative exponent rule. Okay. And let's do this guy. I've got first divide the numbers out, 32 over 24. Again, you're finding the greatest common factor that goes in there, which I believe is 6. So I've got 4 over 3. Again, Desmos will do this for you. Then I'm moving on to the x's. So I've got x is my base. And I've got negative 3 minus 4. Well, negative 3 minus 4, same signs we add, so it's a negative 7. Then I've got the y. That would be my base. And I've got y to no power, which is really, if it's not there, it's a 1. So I've got 1 minus 0. And I know 1 minus 0 is just 1. And I don't have to put the 1 there because I know if it doesn't have the 1 there, it's automatically that. However, this guy's unhappy. So I'm going to take 4's on top, y stays. The 3 is already on bottom, so I'm going to put him down there, and I'm also moving that x now to the bottom and making him happy. That's 7 positive now. So that's what we've learned so far. This is what we've covered on our properties of exponents. We have 2 more to cover, and today we're going to be honing in on power to a power. That's the rule we're going to be talking about today. So here's the rule. So remember we said if we multiply, we add exponents. If we divide, we subtract exponents. If you have an exponent and raised to the power of another exponent, you're going to multiply. You're going to multiply the exponents. So here, I've got x to the 12th power, but then I'm raising that whole x to the 12th to the second power. So what's really happening is what? I've got my base is now this whole thing, okay? That's the base. The 2 is my new exponent. So what I'm really saying is I've got x to the 12th times x to the 12th. I have that whole thing 2 times. So if we did our power rules, so now I have the multiplication power rule, right? And if I multiply, I really add the exponents. So now I've got a base of x, right? I add the exponents, and I have 12 plus 12 is 24. Okay, same thing if I didn't do that all out. The rule is a little shortcut. That's kind of what this, all these rules do. They save you time from having to simplify and do it all this way. There's a shortcut rule. All I have to do is take this exponent here and multiply it by this exponent here. And I get 24, which is what I got here. But that's how you get that 24. So here, instead of having to say x to the third times x to the third times x to the third times x to the third, I mean, these numbers could get pretty big. Like you could be multiplying a bunch of monomials out multiple different times. Instead of having to do all this and then add all the exponents up, we could just say 4 times 3. Keep the base is 12. Right? Okay, 10, I'm doing a half times 10. Well, half of 10 is 5. Pretty easy, right? I feel like this is probably one of the easiest ones there is. There's one more that's pretty easy too. 6 times 2/3. So I've got 6 over 1 times 2/3. Again, you can use Desmos. But if you didn't, we get 4. So I've got x to the 4th power. Okay, so pretty good so far. Okay, what happens if you have more than one base in your problem? You're going to distribute it. So when solving equations, we learned about distributing. If I have 3x plus 4, what do I have to do if I'm simplifying this? I've got to take this 3 and multiply it by everything on the inside. I'm left with 3 times x, so it's 3x, plus 3 times 4 is 12. That would be distributing, right? Same thing here. You're going to have to take this 2 and multiply it times every exponent inside of here. And you're going to keep the same bases, so we've got x and a y. But I've got 2 times 3 is 6, so I've got x to the power of 6. And then I've got 2 times 5, which is 10, so y to the power of 10. That's all you do. So it's the same idea as if the 2 were out in front here and you were doing it this way, but it's just on top. Where'd the other problem go? Down here. Okay, so same thing here. I'm taking this half, has to be multiplied by everything inside. So I've got the base of A, 10 times a half is 5. Base of B, 4 times a half is 2. Try this one. Go ahead and pause me and we'll go over it. Okay, so if you noticed, m doesn't have an exponent, so it's really a 1. No big deal. I'm going to take this 2 and multiply it by everything. So I've got m, 1 times 2 is 2. And in 3 times 2 is 6. Okay, what happens if there's a number there? Same thing. You treat it just like we've been treating everything else. I can't just take this 3 and multiply it by these two things. When you distribute, you multiply by everything. So I've got to multiply by everything. Well, 4 doesn't have an exponent. If it doesn't have an exponent, it's automatically just a 1. So I really have 4 to the third power, because 1 times 3 is 3, which can be simplified even further to be 4 times 4 times 4, which is 4 times 4 is 16, times 4 is 64. Then I continue on. I've got x, and 2 times 3 is 6, and I've got y. 4 times 3 is 12. Ta-da! So treat it just like it. It's got to get multiplied out. Okay, so let's put all the rules together. So we're going to put everything we've learned so far. All of this. Product of powers, quotient of powers, power to power, negative exponent, and maybe the rational zero theorem. We'll see. Okay, so here we are dividing. But first, I've got this power going on, okay? So the first step I need you to do, number 1, is power to power. Okay, that's what's happening here. This 2 is going to everything inside, even that 3, yes. And that 3 has an exponent of 1, and that y also has an exponent of 1. So that's what I'm going to do first. I'm just going to simplify the top. The bottom staying the same. I'm just carrying this bottom over. It's the same thing. So I've got 3 to the power of 2, right? Which is really 3 times 3, which is 9. Okay, then I've got x. 2 times 3 is 6. And y, 1 times 2 is 2. Okay, so that's the power to power. Then, rule number 2 is the quotient rule. Okay, so now we're dividing. I'm going to divide the numbers out, which there are no numbers, right? It's just 9, so 9 is going to stay. Then I'm going to take the x's, okay? Let me get a different color. X is my base. Sorry, you can't really see that. And I've got a 6, and there's nothing here, so I know it's a 1. So I've got x, and I've got 6 minus 1, which is 5. Okay, y to the 2. Now we can sit there and do like what we've been doing. I've got a y. So y would be the base, and then I've got 2 minus 2. Well, 2 minus 2 is 0. There's no more left. If you have anything on top and bottom, that's the exact same. It's got to have the same base and the same power. You can just cancel it out. It's gone. So my answer should be 9x to the 5th power. Okay, here. First, I've got to deal with these exponents, okay? Remember PEMDAS. Parentheses. Exponents, then multiply. So first I have to exponent it out. 3 goes to everything inside. So I really have 4 to the 3rd power times x to the 9th, right? 3 times 3 is 9. Well, 4 to the 3rd is really 4 times 4 is 16 times 4 is 64. And then x to the 9th. Here, I've got to, again, do this guy out here. And I've got x to the 6. 2 times 3 is 6. Okay, now I can combine these by multiplying. Multiply the numbers first. Sorry, skipped a step there. Multiply numbers first. Again, it's just 64. There's no other number. That's what I did first. Then I'm moving on to the x's here. And I've got multiplying, so I've got 9 plus 6. We're going to add those together, which is 15. So again, putting all this up together, you know how to do all of it. It's just knowing what to do first and making sure you get everything in there before you move on. So powers first, then you move on to your multiplying and dividing, all that jazz. Okay. This guy, the half is going to go to everything inside, even the 25, yes. So I've got 25 to the half power times x, 10 divided by A half is what? 5. And y. 4 divided by half is 2. Now this 25 to the half power. We are going to learn about this tomorrow. More about how to do these types of problems. Your calculator will do it for you. 25 to the half power is 5. Okay, it's I really don't want to go into it. We're gonna be talking about it. It's gonna make it into what you're really doing when you take a half is you're taking the square root of 25. Like if I did 9 to the half power would be 3 because the square root of 9 is 3. I'm not gonna, again, I don't want to go too far into this because it kind of steps on what we're doing tomorrow, and I don't want to get us too ahead and confused. So for now, just know if it's to a half power, you're taking the square root of whatever the number is. And the square root of 25 is 5. And then I've got x to the 5th and y to the 2nd, or y squared. There's my answer. Okay, 12. Okay, I've got to take the 0 and multiply it times everything. Now, I learned, though, that anything to the 0 power is 1. So this whole thing is going to cancel out, and it's going to make just a 1. Okay? You don't have to sit there and do all the math. It's all 1. That's all it is. And I know 1 times anything is the other thing over here. So, but now basically I'm just left with dealing with this. So now I can focus on taking this 3 and putting it to everything inside the parentheses. So 2 to the 3rd power. X 3 times 3 is 9. Y 3 times 4 is 12. Well, 2 to the 3rd power is really 2 times 2 is 4 times 2 is 8. X to the 9th power, y to the 12th. So that's pretty cool when this happens and you've got like a big long monomial or polynomial or whatever it is, the 0 power, it just makes 1. It cancels out. It's gone. Which we talked about yesterday, why that happens. Okay. What is the area of a square with a side length of 4x? So again, special about squares, all the sides are the same. If that's 4x, all the sides are 4x. If I do area equals length times width. Now remember we talked about the special thing about squares is all the sides are the same. So it doesn't really have a length and a width. It's just called a side because all the sides are the same. So what I'm really doing is side times side. Yes, I know what I just wrote, but I really needed to write this for purposes, so please ignore the word there. But A equals S times S, side times side. Well, if I were to write this shorthand with exponents, my base is the S, so I've got A equals a base of S, and I've got it 2 times. So A equals S squared. A equals S squared. So now I can plug in what I know. I know that the side, wow, that was a bad choice. I know that the side is 4x. So we're seeing S, I'm putting in 4x. So A equals 4x squared. Now I take the 2 and I multiply it times everything inside. 4 to the power of 2, which is really 4 times 4 is 16. And then x doesn't have a power, so it's really 1. 2 times 1 is 2. So area equals 16x squared. And that's it. And yes, you could have solved it just by plugging in area equals 4x times 4x. Multiply the numbers. Keep the base. And I've got 2 of them. Same thing. I did it this way though because we've been talking about exponents and power to power. So that's why I did it the long way. But either way would have worked. If you were solving it on something, I would have taken either way. Okay, that is power to power.